For parametric that there's direction because it's based on time. So a reminder on your parametrics, we will define the x's and y's in terms of time. So if you are asked to graph the parametric, you just make a time xy chart. If they tell you it's for time greater than or equal to 0, then you start at 0. Typically, we did -2 to +2. Okay, and then you plot the points and you indicate direction with the arrow as you went through time. Calculus. We need to be able to do tangent lines. So to do tangent lines, we need to be able to do slope and a point. Okay. To get the point, you will plug in whatever the time is into here to get the x-coordinate and into here to get the y-coordinate. Okay, so you need to know how to find the slope, which is the derivative for parametrics. Okay, so to find the slope, we have done this part before. Still dy dx, slope, derivative, all the same stuff. To do this, whatever your y function is, take its derivative and put it on top.
This was the one I liked because it was just really easy.
And to do the derivative for x on the bottom, whatever your x function is, take its derivative and put it on bottom. Please notice this is not the quotient rule. You don't put y over x and then do the quotient rule. You literally, it's like the dream quotient rule that you guys all wanted to be the quotient rule. Well, wouldn't it just make sense if I put the derivative of the top and the derivative of the bottom? Okay, so that's the gist. And you've done this before, you guys. We did this back toward the beginning when we were first doing derivatives.
It's like L'Hopital's, right?
Just talking about the separation.
The separation of it, yes. Okay. Second derivative is more thoughtful. We didn't do second derivative. Okay. So this is where I'm at. Algebra before calculus. Once you get the first derivative, make sure you have completely simplified the first derivative before you go on to do the second derivative, because it's a twist of getting the second derivative. So I need to make sure you know how to get your second derivative. So what does second derivative tell me about a function?
Concavity.
Perfect. Okay, so when you are doing the second derivative, when you have this is typically by design, you will have a quotient out here. So to do the second derivative, you will almost always have to do the quotient rule. Okay, so it is your second derivative, so just regular second derivative. But then you have to put it over g prime again. Okay, so you have to put it over dx again. Okay, so it's this whole second derivative. So whatever this is, take its derivative.
Something over something. No.
It is something over something over something, but we are really good at complex fractions in this class. Okay, so it is over, now watch. This is my make sure, this is like the danger. You have this, and I just told you to simplify as much as you can before you go on to the next step. So you have your simplified first derivative, quotient rule to get your top. Okay. This, whatever this simplified down to, that isn't what goes here. It's not what you got when you reduced. It's straight up g prime. Okay, so I'm going to do a problem and walk you through to make sure you guys see what I'm talking about when you're doing these. Okay, so we're going to start with derivatives and we'll talk about tangent lines for them.
So is this an example?
An example.
Oh yeah, we discussed it.
Yes.
Oh, wait, that's not an X. Joking. It's a T. I swear it is. There we go.
I crap this all the time. Sorry.
Come
Okay, this is kind of a weird question, but why is it d to the 2?
It's just so that you can tell the difference between a second derivative and that it's squared.
No, but
So one of them has to be in the middle.
Oh, okay.
Because if you had it both at the end, it would look like it was the derivative squared, which is not what it is.
Okay.
Okay, so just do the derivative for right now. Okay, just find dy dx. You guys have done this before. These are typical questions. They're going to ask you about vertical and horizontal tangents because you're almost guaranteed to have a fraction. So you're guaranteed to have a top and a bottom. So they're easy follow-up questions. So I'm going to run through a series of questions at the end.
Neither do I.
Okay, you guys are freaking me out because you're doing like chain rule stuff and there's no chain rule on this.
Oh god.
This is the equivalent.
Oh. Alright.
Okay. Derivative at the top, or derivative of y over derivative of x, derivative sign is cosine. The derivative of the top, you should have a 1/2 t, is that right?
Yeah.
Okay. So now, this is what I'm going to ask. I want the equation for the tangent line find the equation for the tangent line at time equals pi. So you need two things for an equation for a tangent line. What are the two things you need for a tangent line? Slope and a point. Okay, dy dx gives you slope. How do you find the point?
You plug it back into the
Back into the thing when we did time x, y charts in order to plot points. Okay.
Yeah, it's just,
It's a long really gross. Yes. I had that moment too. Whoa, what?
oh, what?
No,
Huh?
because cosine of pi is like
Oh, okay. Oh my goodness, I read it pi over 2 and I was like, I'm so wrong. Why? Some Monday. Solid. Also really unhappy number. Yeah,
Okay, so just a reminder of things like how to find points on parametrics. That's why we did parametrics last year. So to write your equation for your tangent line, it is y minus your y value. I still leave it in point slope form. Okay, so I'm still going to do y minus my y value is equal to slope x minus your x value. You can put x minus 0 or just leave it as x. Okay, so when they ask you for tangent line, slope and a point, slope with our derivative stuff, point with our old parametric. Okay, so now that's my next question. With the same thing. These are perfect follow-up questions because you had the derivative of y over the derivative of x. So they're going to ask you about vertical and horizontal because you have fractions. Okay, so you need to remember which do you set equal to 0 for vertical and which do you set equal for horizontal. So you need to remember the slope. If you had Schneid, write on in no way. Usually helps you get there.
I remember now what right on is. Right on.
0 or number over 0.
Well, yeah. Oh, on.
You guys did these way back when.
So I did, horizontal. So horizontal, you said the
going to just resolve.
I think that's right.
Yeah. And then for vertical, you try to find the equal. Okay. I just want to make sure.
You guys put a star. Your quiz and chapter test will absolutely ask you about vertical and horizontal tangents because the AP test always asks this. So for vertical tangents,
Bottom or top is it? I decided horizontal first.
Oh my gosh.
all right, so for vertical tangents, top or bottom equal to 0?
Top.
No.
Bottom.
Vertical has an undefined slope. When you have an undefined slope, your 0 is under on the bottom.
Yes.
Horizontal has a slope of 0. Okay, put a star. You will be required to know this for the AP test, absolutely.
And I said don't say your own stuff because I just don't understand it. But I got this. No, triangle don't fit in square. I know. Sometimes the right triangles do.
All right, you guys, so vertical tangents, when is cosine 0? Pi over 2 and?
Pi over 2.
And?
Plus 2 pi. You know, in table negative
Cavalry has it. You have to include period for your trig functions. Okay, so pi over 2 and 3 pi over 2 is just the basics from the unit circle, but the 2k pi. Oh, don't wait, stop.
There's 2.
Phew. At time equals.
Literally one
Um, For the plus 2k pi, you have to do it for both.
I just always
Okay.
give it to you.
Cosine.
Okay, so now you guys, what if I ask for the equation for the vertical tangent lines?
Just
So we know
Go
when
back and plug it into all the slope of the x and the y.
vertical tangent lines.
No, it'd just be x.
Wait,
yes.
Okay, vertical tangent lines are just, that's why I was like, oh wait, this can't be x because I was starting to write the equation. Vertical tangent lines, vertical lines are x equals. So you take those times, you go back to the x and you find your x. And that will be the equation for your vertical tangent. So when you go back to x is sine t. Okay, so when you plug in pi over 2, what's sine of pi over 2?
1, 1.
And 3 pi over 2? And that's the whole 2k pi. It's just going to keep bouncing back and forth between 1 and negative 1. So you have two vertical tangent lines. You have a tangent line at x equals 1, and you have a tangent line at x equals negative 1.
Can you make commas? I mean, like, write x equals 1.
Oh, I don't care.
Okay.
Now here you guys tell me the time when you had a horizontal slope and then write the equation for the horizontal tangent line. The parametric stuff is relatively easy. But you definitely are going to have to go back over vertical and horizontal.
It should be.
Is this all this section is, or is it going to get harder?
Then we need to do arc length. And no, they're all just formulas.
Oh, okay.
It's today is just like here are formulas, put them on your green sheet, memorize them. Like for me, it's my dream because I can follow the formula. All right, time equals 0. So when you plug it in, you got y equaled negative 1.
Yeah.
Okay. Is that right? Yes. Yes. All right. So we have done tangents vertical, tangents horizontal, tangent at a particular time. Take this and find the second derivative. Okay, take this and find the second derivative. So second derivative back over dx again. And on this one, there wasn't anything that we reduced, or I didn't reduce it. So quotient rule over dx again.
Oh. I was like, it's G prime, but it's not squared. It's like, why isn't it square? Okay. That makes more sense.
Sounds good, Muriel.
Okay, so should we suffuse? It is this.
At the very end, we need to simplify. Like, they'll never leave like some crazy algebra thing on the AP test. I'm not done, but I want you to see that this was my second derivative. And you guys remember here that it was minus, but the derivative of cosine was negative sign. Okay, so that part is where that plus came from. So this was the second derivative all over dx, and now finish simplifying. So you end up with a cosine cubed in the denominator.
So why would it be cubed instead of just the C that if you move it up?
Because it's this divided by this. It's this times its reciprocal. So it's going to the bottom with the sign.
But this is cosine. Okay, so it's 1 cosine plus 1 t sine t
Oh no.
t squared.
And then divided by this, so divided by this, which is times its reciprocal.
Oh. Sometimes it's fair. Sometimes.
You guys, only little comments because this is actually, once you know how to do it, you're like, actually, it's not horrible. You don't love the quotient rule, but it's fine. Here, when you write it, be careful where you place your exponent. So look, your options are, it goes in between the cosine and the variable, or that it is outside parentheses. Please notice, what does it mean if I write that? That the t is cubed, not that cosine is cubed. Okay, so your choices are in between, tells you that it's cosine cubed, or outside the entire parenthesis, but not just shoved at the end, because then that means your variable is cubed and not the function is cubed. And again, you guys, what will they ask you questions about with this derivative? Concavity, is it concave up or concave down? That kind of thing. Alright. Okay. We're going to keep going. Oh, notes. Formulas. You will add these formulas onto your green sheet. First derivative we already had. Second derivative you'll add on. Then we have arc length and surface area. They are just formulas, you guys. You plug it in and simplify it. Okay, so arc length formula.
Just give us the green sheet.
So, who remembers back with a regular function?
It's the
Square. Okay,
Isn't the integration of the square root of 1 plus the derivative squared?
okay, so that's for a regular function. So you guys are going to have to pay attention when you take need-to-know quizzes. What arc length am I asking about? So that's if I'm asking about a function in terms of either x or y. Okay, that's your formula. Parametric. We have x's and y's and time. Okay, so this arc length formula is a little bit different than a regular function, so you're going to need to keep them straight. And on your formula sheet, make sure you note, so it is still a giant square root. Your limits of integration are going to be time. This is going to be a dt at the end. But you guys, you're going to have to take into consideration the x's and the y's. So it is going to be your derivative of y with respect to time squared, and then your derivative of x with respect to time squared. Like before we took the derivative of the function and squared it, well, but now we have two pieces, so the derivative of each piece squared. So I'm going to do just super fast sample, make sure you guys know how to do it. So if I give you x is cosine cubed, and y is sine cubed, and I am asking you to find the arc length from 0 to pi over 2. This derivative requires the chain rule because this is cosine of t cubed. Every time we add trig, we put it with parentheses outside to help us remember chain rule. Well, remember, we're like in full swing of BC, so they are definitely expecting all of the 80 stuff is solid.
Oh man.
Be careful on your derivative, you guys.
It doesn't matter.
Okay, so check. Okay, for the chain rule, derivative of the outside, so my exponent rule. Exponent goes in front, it goes down by 1. So that's the derivative of the outside, times the derivative of the inside. The derivative of cosine is negative sine, and then repeated for the other one. So those are just the derivatives. Now you get to square them, add them, square root them, and still integrate.
When you square, can you just like distribute the thing, the little square into each, or do you actually
Because there's no plus or minus, you just square each piece.
thank God. Okay.
If there's a plus or minus, then you have to FOIL it out.
Yeah.
But there's not, so it's good.
Oh man.
We have a quiz Friday, and then chapter test the following Friday, and then we go for spring break and then come back and study for the AP test.
Ooh.
How long is that after spring break? How long? We have a month.
Is it 3 weeks or a month?
You can take it out.
I don't know, it's on my calendar.
Those are the same thing.
No, it's like 4 weeks or 3 weeks.
3 weeks. I was like 15 months.
I don't understand your logic. Just tell them.
If you count moves.
Which is what?
One square.
See, we get it right. We get it right.
Okay, you guys, this is a non-calculator question. Keep going.
Did it, Lauren?
Lauren, what's the trick?
Cosine squared t plus sine squared t equals 1.
So you pull it out
until you get
You guys have GCFs that you can pull out, and then you'll have a sine squared plus cosine squared.
Cosine t sine t.
There you go.
And then I can integrate. I
Yes.
don't know if I can. This is so exciting.
No, you can.
Okay.
So you take this one out, you go cosine squared t, and then you have times
You.
squared
I use U's.
okay. T.
I'm gonna do sine. It's class.
Yeah, I always make, if I have the choice, sine, because the derivative's easier.
Oh, sine is positive, sweetheart. I did use sine.
Cosine times sine is
No, you pull, if you pull out, pull up 9. Pull up the 9 cosine squared plus, or 9 cosine squared
That
sine
was like,
squared. Because then
Yeah,
that
but
leaves
there's a
cosine.
GCF. Pull out the GCF and not whole thing.
Oh.
Wait, you deleted that.
Oh, wait, no, I did that. Plus. No, it's not. Well, it's minus 3 then.
Because this is the parentheses on here.
I just put them on the side.
Beautiful people.
By hand, you guys finish it. It's a by hand integration.
Are you ready to
So you would just say like
I prefer to let you know that it technically doesn't matter, but I prefer because then I don't have to be negative.
Don't be a burden.
they had if it's the same they won't turn green. That's it.
Well, yeah, ever factor. I pull out the D's and the F's.
Lines up.
It's outside so close. Like we have inside these little kids both there having.
But they just it's not like an individual thing.
So if it's just a bunch of shells. Yeah. Yeah, we're graduating.
Have fun.
9 cosine squared sine squared. And then I was left once I factored it out.
At least
I did it. So we like really cash
Fine, fine.
So watch. So
Okay, what is he
I feel it's
I pulled the 9 out,
Okay,
so that's there. Okay. Then these have a cosine squared, so I pulled that out. And then these also have a sine squared. Okay. So now these are two separate terms. So for this one, when I factored out the 9, the cosine squared, and the sine squared, when I factor it out, I just left with the cosine squared. So that's why this is my first term in the parentheses for what's left. And then same thing here, when I divided the 9, the cosine squared, and the sine squared out, I was just left with the sine squared for my second term. Okay. You guys remember when you do U substitution, you do not plug in 0 and pi over 2 here. When I switch and I do U substitution, please notice that I leave off my limits of integration so that I am not tempted to start plugging those limits in when I have U's. You have to get back to T's before you can plug in time limits of integrations. Okay. So that was an issue when we did our integration test and quiz. You guys were forgetting to get all the way back to the original variable.
I know this sounds funny, but you could do cosine as U, right?
Yep, yep.
Okay.
It's I don't because then I have to deal with negatives because derivative cosine's negative sign.
Yeah.
And I don't really like negatives so much.
Makes sense.
Negatives do suck.
I was just like, wait.
Do you guys get 3 halves?
Yeah.
Yes, no?
Yes.
Okay. All right, so formulas, we have one more formula. Make sure you guys have in your notes the derivative formula for parametric. It is not quotient, it's just derivative of y over derivative of x. That is on your sheet I gave you guys. Also, make sure you know how to do a second derivative for parametric. Second derivative over the original dx, not like the reduced dx. Okay, arc length, you guys, are supposed to be really straightforward problems. It's not like you don't have to graph it, you don't have to visualize it, you don't have to like rotate it anywhere, you just have to plug it into a formula. Okay, but it is going to test your integration and derivative skills. Okay, so lastly, surface area formula.
Oh, man.
It's- Today's just formulas. Add them onto your sheet, make sure you memorize them for Friday and next week, and then the AP test. All right, so surface area formulas. Well, it depends on what axis you're revolving it around. Okay, so surface area, you're required to take that parametric thing and rotate it. So it depends what axis you're rotating it around. Oh, it's all good. So if you are going about the x-axis, your surface area formula is the integral. These are again in terms of time. Two pi y. But remember, you guys, it's in terms of time, so it's not just straight up the letter y. Okay, it's whatever the function was. And then your arc length. Okay, so before it was 2 pi x or 2 pi y and then times your arc length, so it's the same thing, but your arc length formula is dy dt squared dx dt squared dt. Make a note, for that y, it is not the letter y. It is the function in terms of time. So like f of t or g of t, like something, however you defined it. So in fact, up here, watch, I'm going to write this. Oh, I'm not, but I will. Okay, here we go. So I'm going to write this. So this is what would be in for that y. Do not put the letter y. Whatever the function was in terms of time of y, that's what you put there. So if it is about the x-axis, it is the y that goes in there, so let's make a big leap. If it's about the y-axis, let's think how we could possibly rework that to go about the y-axis.
I'm stuck.
Okay, so it's not that the formula is difficult. So I'm going to do one just to make sure you guys remember not to put the letter y, but to put the function y or the function x. Times again 2 pi, so about the y, so it's the x, and then root dy dt squared dx dt. I am including, they are not particular about if you have dx's, dy's, or dt's. The reason why I'm doing that is to remind you that everything needs to be in terms of time. The x needs to be in terms of time, not an x. Your limits of integration need to be in terms of time, not x's or y's. Okay, so let's take a happy, easy problem and be done.
Thank the Lord.
Okay, so let's leave that there. So just make sure you guys are happy on plugging stuff in. Find the surface area for the function x equals cosine t. Nope, put a 3. Y equals 3 sine t. From 0 to pi over 3. Do you remember before where we had to draw it, we had to reflect it? Just don't even care, you guys. Plug it into the formula. Okay, let's see what you get. You definitely should be able to integrate this by hand. So we're going to have like our trig reducing substitution stuff. Check at the end. Okay, so I gave you the answer. Check and see if you can get there.
Oh, 9 pi. I thought it was 0 over pi. I was like, that makes sense.
Yeah, 0 over pi, of course.
It's one of those things.
There's a horizontal zeros on top.
I know. I got you right now.
Yes, that's one. So they're just square root of 3.
Something that's going on in my head. They lose myself.
Square t plus sine
No.
squared t, so it's just 3 times 1, which is 3, so it's just the square root of 3.
The sharpening job, that's the sharpening.
Wait. No. No, it's a 9.
Yeah, they both suck.
We forgot to square them.
Oh, they stole this from somebody.
Whoa. Wait, I was right. Okay. Oh, yeah. This is
Plus 2.
okay.
Plus 18 pi, which is not the correct answer.
I like 9. Where did Laura and I go wrong? Wow. Oh my god, pi over 3 is not root 2 over 2, okay? What?
I was like, that is not the answer you ended up with. Pi over 3 is it 1 half? No.
What is pi over 3?
Square root 3 over 2. How 1 half?
It should be 1/2.
No,
1/3
pi
over
over
2.
1 half root 3 over 2, so the
Because
cosine.
pi over 3 is up here, so the x coordinate is going to be smaller
So
than
it's
the y
yeah, 1
coordinate.
half root 3 over 2, so cosine.
Alphabetical order. Cosine comes first, it gets the first coordinate. Sine comes
So
second,
it's
it gets the
1/2.
second coordinate.
Not root 3 over 2? Okay.
Hey, that's me.
3 times 1 half. So that's negative cosine.
It's funny.
Oh, wait, so
you're
pi cosine. It's negative. Wait, I need to negative 18 pi over 2. Shoot,
I told you mine is Wait, yes. Oh wait, that's supposed to be plus.
8 pi plus 18 pi equals 9 pi.
Okay, so you guys, you always,
Stuck a little bit.
and on your need to know quizzes, I will still put in exact values for trig because at any given time, they show up. Okay.
Oh wow.
Oh, I got it too. As I said,
sorry. Cosine is 1, right?
So I'm gonna pull the negative 18 pi out,
I mean,
and
1.
then
0.
cosine of pi over 3 is 1/2,
Since 0 is 1.
and cosine of 0 is 1. So this is negative 1/2 with the negative 18 is where the 9 pi comes in. Okay, so lots of trig is gonna come in, not like ridiculous trig, just like, ooh, whoops, forgot that trig, but you guys know it. Alright, so for today's stuff, start numbering packets over, so start on packet number 1. We are on collaboration, but you still have actually more time than we usually have on collaboration for homework. And then tomorrow we start vectors. So this is your one day on parametrics. Know the formulas, put them on your formula sheet.
Oh, I ready.
Normal, right?
Oh, did you? Okay, I totally forgot about Gabby until
This is
now.
a-
It's a good thing you did it. She's at your
Thanks,
John.
Welcome. See your name. I can come.
You're funny.
Oh, I know.
She's there. She's meeting with the professor. She's only there Monday. On Mondays, and like.
Hey, we'll get you on the green book.
He's going there for.
Who?
He likes it there.
What's it?
Well, you know, getting stuff
Here you go, Meryl.
Well, we'll transfer. Yeah, still wrong. I became nuts.
Working until like 9:30.
How late is this open? 9. They were open till 10 last week.
That's so
We're open till 10 on Fridays and Saturdays.
Okay, get a new book.
A year.
And we're gonna drop. See, I'm not, because it's for like, I don't wanna spend my last.
When is that?
So I talked to Gavin about it, and she said that it's kind of like a career fair, but they also are having like companies in Rapid that are hiring.
Yeah, they're doing interviews
Yeah.
on the spot.
Yeah, so.
So should we like get
Wow.
dressed nice?
Yeah, and
Wait,
like
for
for
what?
resume references.
Wait,
If you're like looking for another job. Wednesdays is like a career fair, and then. And she said go to the thing before, like the resume or like the how to get a job thing before the thing starts at like 6.
Oh yeah, I'm actually looking for a summer job because
Yeah.
I have one, but it's only for 3 weeks.
Are you doing that?
So you are going to go to it also? Yeah. I just really like needed to have her.
I'm gonna get a summer job.
Wait, what time?
6:30.
It's like the one time.
I'm not really sure.
I have the flyer up there. The career
But she
flyer's
said
on
get
my
there
board.
like
Yeah, there's like a seminar thing or something.
They're doing breakout sessions also.
Yeah,
and it's tomorrow.
So we can have.
Wednesday.
Wednesday. You'll be in Gaul, honey.
See, I see. I'll skip it.
Oh yeah, that's gonna leave like a rocket in me.
Maybe.
No. Prior.
Yes.
For the registration fair, what do we do?
What were we supposed to do? Typically they've done senior meeting then,
Yeah.
but I
Okay.
don't actually know.
I think it is.
Oh,
There's
there's
senior
yeah.
meeting.
Second block, I think it's tomorrow that they have the Cassie. They're making the seniors take the S back
Wait, what do we
along
do?
with the juniors. The seniors have to take the S back too.
The same thing doesn't happen as when I called last week to make sure thumbs up for giving it to my juniors, and I'm like, okay, I'm freaking out. Like, what if I accidentally give a real test? They're like, no, the real test isn't up until April. Just pick one of the tests and give it. I'm like, are you sure? Yes, just go for it. No, I gave the real test on Tuesday.
Yeah, we have to take. Oh yeah, we have to take the S
Like-
back.
A fifth of the junior class. So now we have to file for irregularities. And I'm like, no, I called you and asked you. She's like, yeah, I didn't know it was on. Oh, okay.
No, yeah. So all of like Matthew's just making
That's
the
on you.
seniors take the S back too.
What's the next?
It's the well, it's
You
it's
don't
a
have
test.
to do it
It's a
though,
new
right?
test. No, she's making. Matthew's just making it.
Friday, you don't have to do it, right?
The what?
Are you in my class? Of course, my class. Right, I'm going to take time out of calculus and do
No, second block.
Are you gonna make them take it?
Oh, yeah, for sure.
Can I just come over here while they're
High
taking
school
it?
Exeter 10th graders, though. Juniors don't take that.
Juniors are. It's not the high school. It's not Cassie. Juniors, because sophomores are gone tomorrow, so they're taking the practice. Juniors are taking the practice S back while the sophomores are gone.
Oh, but only with Matthews. That's not school wide.
Maybe worrying.
I think because we're in the class.
You're in a mixed class. You have sophomores, juniors, and seniors. So she's trying to figure out how to not completely kill a day. So if sophomores are gone anyway, then everybody who teaches juniors is supposed to be logging them onto the SBAC test so that they know how to log on. So she's trying to do that for because Miss Matthews is like totally, if she's supposed to do something, she definitely does it. So she's trying to do that. I put my seniors on the side of the room and said, if you have homework, go ahead and work on that, and if you need to study, go ahead and do that.
Can I come to your class? Wait, so we have to do it on the computer?
Yeah, on the Chromebooks.
Can we just talk to her and be like, hey, can I just go prior class? Do not do it. Useless.
You can ask her.
That would actually work. I'll totally ask her. There's no point in asking. I'm not.
Dude. I would love to give you her
Thank you.
Welcome.
We're gonna make them think they're better than they are. Yeah, worse than they are. I'd probably be.
Prior. Yeah.
What is Matt's steeple chase?
Me. After the AP
So
test.
far away.
Because I would never send my calculus
No.
kids
No.
if it was right before when we were doing practice
It's
AP
a math
tests.
competition we do every year.
What class am I supposed to be giving these to?
Your
I thought it was
Okay, you guys, does anybody know for the NHS fundraiser what class I'm supposed to be pretty sure they gave me extras.
It's probably your second.
Woo!
Probably second one.
Is there
Probably second one.
I'll see if there's an email.
Order resale.
Oh yeah, make sure.
I have an activity stuck in my head because it's actually from choir, and we're doing this together.
Hey, is the dinner included in the $2 admission?
No.
No.
It's like
Oh, bring money for food and drinks. I just need to read one more line. So,
it's like I think it's like $2.
I think we're
pre-selling
food tickets.
No, we're not.
No.
We're not pre-selling food tickets. We all thought that was a dumb idea. We're pre-selling tickets, just not food tickets.
Why?
When is this? Because why? Because we're not.
No, it would have worked out. It was just gonna be more like complications.
It was.
It's just
completely
one more.
unnecessary.
It was one more thing to worry about. If people are gonna buy food, then we could.
the reason why typically they do pre-sales is then if somebody doesn't show up, you already had their money. And then two, it helps you to try to budget how much food to buy so you don't have so much wasted.
We're
at the end.
asking when
So
people
those are
buy
two
the
reasons.
tickets. When we're asking when people buy pre-sale tickets, we're asking them, would you most likely buy food there so that we can get a better idea. We don't even have an idea of how many people are going to show up.
Does it say outdoor?
I'm
on
there. I love that movie.
I've never
movie
seen
is
it.
Wait,
so
I
good.
hadn't either. I was in
Good.
the dentist's office with Allie and it played and it happened to be like the day she got
Is it
like
really so
x-rays and
good?
x-rays.
It is so
No,
good.
you know,
For a math nerd, it's so good.
Big Hero 6.
You know what's really
Oh,
funny?
I
This
love
part
Big Hero 6.
is when I watched it, I was with like my mom and like her best friend has like, a bunch of like little like 3 little kids or 4 little kids. And they only go like this is their big movie, right? And they're like, would you come along, come watch the kids with us? Yeah, whatever, I'll go watch it. And my mom and her best friend are both nurses. And they kept making about like the 6.
Oh.
And I was like, oh, except my mom and her best friend were laughing more than the kids.
Oh, I was cracking up. I'm always
It was
embarrassed.
so
like how much I
good.
laugh at Disney movies.
Wait, moral of the story is you guys should all come on Friday.
It's so.
I am.
It's
and
so
I'm
nerdy
buying
and
picking up
creative,
my
but
little
it's
like
like-
Wonder Girls. And
Hey,
stuff
no,
like
it's
that.
way
in the
cheaper than
theater?
going to the movie theater.
It just got out.
Yeah, I was just thinking about that. This is the same thing
It's
since
zero.
Theater.
It's such a good
It's
movie.
zero.
It is good.
The second part. I was so
did
high.
this? Is this still going, Cole?
Huh?
Have we been recording our Big Hero 6? See, but then I really feel like they were here and had a. She'll be like, did she keep teaching? Like, can we keep watching this?
Shh, don't talk.